Hello everyone. First of all, I want to thank all my subscribers, my viewers, my students, and obviously all my mentors. Today, my channel Illustraca have got uh, 3,000 subscribers. We have completed 3,000 mark, and I'm thankful to all of you who are supporting me over these days. And I hope with all of your support, we will go more and more. We will create more contents for the students and professionals, and I hope that we will grow more. So, thank you all of you. So, in this video, you're gonna see that how you can create a section and how you can calculate the cross-sectional properties of that section in Staad Pro. So before that, we will do some manual calc to just match the calculation that we have in the Staad Pro software. So you can see here, I have created a pretty simple section. You can say it is built-up section, though it is I section. So here we have here two plates of 350 by 12. 12 is nothing but the thickness, and we have this web. The flanges are of 350 by 12 and the web is of 600 by 8. Okay, so thickness of the web is 8 mm. Now what we have to do, we will find out the moment of inertia and area and all, so that we can match the sectional properties that we are getting from the software. So let us just calculate first the area. So it is very simple. We have 350 by 12, so we have 2 times, plus we have 600 by 600 times 8. So let us just calculate this. This is very simple thing. So 2 multiplied by 350. You can also do this by yourself. You can make the calculation. It's not a very tough thing. So yeah, it will be 13200 mm square, right? So we have got the total area of this member, the whole member. Now you can see that we have two axes. One is x axis and another one is y axis. Okay, so in the two direction we have this neutral axis. Now why this is this axis we will consider the center of the member, because we are considering that this member is a symmetrical member, and this you can see two sides, same sections we have. Okay, so obviously it is a symmetrical section we are considering, so that's why it is at the center of the member. Similarly here also y axis, it is at the very center, because this side and this side we are having same dimensions. So that is we are considering. Okay, so considering that, what we will do, we will calculate the moment of inertia about x and y axis. So let us find out the I axis. So what will be the I axis? Let's go with this one first, and these two members as the second one. Okay, so the first one, it is if you see the neutral axis at the center of this, or you can say at the mid of this member. So obviously there is no shift, so we can just write it b multiplied by d cube by 12, bd cube by 12. We have got the moment of inertia of this, the middle wave. Then we have 2 times this flanges, right, the same dimension. So I will just add it, plus 2 times. So what we have this 2. So what we can do, bd cube by 12 we need to write. Now in that case the b will be 350. So 350 12 cube by 12. Okay, bd cube by 12, plus now these two members are not at the neutral axis, right? There is a shift between the neutral axis of these members and the neutral axis of the section as a whole, right? So let us find out what is the shift. So if you find out this shift, how much it will be. So you can see here we have 600 mm depth for this whole section, right? So half it will be 300 plus half of this section. So this section we know that this is 12 mm section, so it will be 300 plus 6. Half of this section, it will be 306. So the shift will be 6. So what we have, the parallel axis theorem, it will be I xx of this member plus area of this member multiplied by the shift square, right? I in plus ah square, right? So let us just write it here. What is the area? Obviously it will be 350 multiplied by 12 multiplied by 8 square. So this is the shift, so it will be 306 square. Okay, so let us just calculate this, how much we are getting. 8 multiplied by 600 cube by 12 plus 2 times 350 multiplied by 12 cube by 12 plus 350 multiplied by 12 multiplied by 300 square. So the answer we are getting, it is 930643200. Yeah, and it will be in mm power 4, right? So this is the I-axis that we have got about the x-axis for this whole section, right? Now let us find out the IYY also. What is the IYY we are getting? Let us find out the IYY. So IYY, obviously now you can see here the y-axis is at the middle of all the sections or all the individual plates. So in that case we can directly what we can do, we can directly write, it will be now 600 multiplied by 8 cube BD cube by 12 plus 2 times, see here, so it will be 12 multiplied by 350 cube by 12, right? So it will be in mm power 4. Same, it will be in mm power 4. So what is the answer for this? The answer for this will be, let me just do it here once again. 2 times 12 350 cube by 12. So the answer for this, it will be 85775600. Okay. mm power 4, right? So can you find out the radius of gyration for this? We can also find out the radius of gyration for this, I guess. So the formula for radius of gyration, let me just move it a bit. So if I write the radius of gyration Rxx, it will be root over Ixx by A. So how much it will be? Ixx we have got 930643200. Total area we have got 13200. So let us see what is the radius of gyration we are getting. So it will be root under 930643200. 930643200 divided by 13200, root under, right? It will be the root. So the answer will be something around 265.52 mm. Okay, and what about radius of gyration about y axis? So it will be Iyy by A. So it will be 85775,600 by 13200. So how much it will be? It will be 85775,600 by 13200. So it will be 80.61 mm, right? So now we have got what we have got. We have got moment of inertia, we have got the area, we have got the radius of gyration, and many more cross-sectional properties you can find out. But now let us check with these values only whether we are getting similar kind of results in our software itself. So let us just open Staad Pro. I am using Staad Pro Connect Edition version 7, and you can use any of the versions actually. In the older version V8i, there will be some difference in the results, but in the updated version they have corrected this. There is no you will not find that much difference in your calculation, manual and the software. Okay, so I will go to specification, and here you will find a tab in the tool menu, which is section wizard. So I will just click on this section wizard, and it will create such a window. Okay, now you will have the section element to like this window to add the elements, and you have this window where you will be actually having this view of the section, and you can calculate this. So what I will do, I will just let me just open this, and here you can see we have 600 by 8 plate, right? So I will just click on select profile. I will select plate. I will not add this from the you can say Indian standard or any other standard. I will just create using the plates. So thickness of the plate I am considering 8, and the thickness you can say the depth we have considered 600 mm for the web, right? So I'll click on OK. Here you can see we have got. Now we just have to rotate this. So I will give the rotation angle of 90 degree and rotate, and I will click on add. So here you can see we have different nodes in this section. It is pretty hard to see in a small window. You can see here we have one. Actually, just let me show you like this. So they have created the section like this, suppose. And we have nodes here, 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 and here. Okay, so and every node has a number. Now let me just show you. Here you can see at the very corner we have 4, in between we have 7, at the end we have 3. Here in the middle section we have 8 and 6, and at the end we have 1, 5, 2. Okay, now what I will do, I will create another section which is of 12 and 350 that we have for the flanges, right? 350 and okay. Now if you see what here I want to add this flange at the top and at the bottom, right? So if I want to put this section at the top, so obviously the center of this one, if I go back to the board, so now I have another section like this, and here also I am having such nodes. Actually here also I have nodes, so here also I am having nodes like this. So obviously this node will be coming here if I want to put this section at the top, and if I want to put this section at the bottom, then this node will be going here at this point, right? So that is the thing we will be doing. This is the concept. If you see here at the bottom we have the node number 6 here. Just look at my cursor. You can see here the node number is 6. So I will click on this assembling and join node. Now which node we will be joining? We will be joining node number 6. You can see it is highlighted with node number 7 here. So I will with node 7. You can see the middle node 7 is highlighted here. Now I will click on add. So you can see it is added here. Similarly, now at the top we have another node with the node number 8. So I will select node number 8, and here at the bottom the mid node is node number 5. So with the node number 5. Okay, you can see this node number 5 is highlighted now as red, and I'll add it here. So the similar section that I have just calculated in here. So the similar section I have created in Staad section wizard. Okay, so this section wizard is very helpful to create and calculate the sectional properties. So you can see what are the plates we have. It is a built-up section with 3 plates. Now let us check what is the sectional property that the software is calculating. So what I will do, I will just click here. If you see here, calculate basic geometry of the section. If I click on here it is giving you all the data regarding this section. So the cross-sectional area we are getting here 13200 mm square. Okay, so let us just check with us. We got 13200 mm square. The radius of let me put it here so that you can easily see this. Okay, I think okay, it's not possible. So yeah, so we can match easily now. You can see here the moment of inertia about y. Okay, here just let me show you here. Just give me 1 second. So here if you see in case of Staad, they are considering you can see here we have y and z axis, but these are not coinciding with the center of the member. But actually, while calculating the section properties, the Staad, what it is doing, it is considering this as y axis. Okay, this is y axis, and this axis, which is coinciding with the center of the member here, this as z axis. Okay, so in our case, it is, we have considered xx, and this one we have considered yy. Right. So if I want to check ixx, so here it is iyy. Okay, and if I want to check iyy of manual calculation, it will be of izz in the software. So it is in software. Okay, and this is in our manual calc. Okay, so let us just check here. If you see here, the ixx we have got 930643200. Let us check whether it is matching. So if you see 930, let me just make it a it is 930643200. Here it is 930643200 power 4. Right, now let us check iyy. So in that case it will be izz. You see moment of inertia about z passing through, so it is 85775600. In our manual calculation also it is 85775600. Now if you see the radius of gyration, let us find out here radius of gyration about y-axis, so it will be about x-axis for us, right? So how much we have got? 265.52. How much they are getting? They are also getting 265.52, right? In our case, the radius of gyration about y-axis, which is in the software, it will be z-axis. So if you see here, radius of gyration about axis parallel to z passing through, so it is 80.61 mm, right? So in our case also it is 80.61 mm. So this is how you can see there are so many properties. You can see the elastic modulus, the plastic modulus, okay, about two axes u and v. Actually this axis is u and the vertical axis is v. Okay, but still it is, while calculating the radius of gyration, or you can say moment of inertia, this u is nothing but y and this v is nothing but z. Okay, so you just have to keep those in mind, and you can just check the other you can say other values also, or other parameters also. Now all these parameters that you have calculated, what you can do, suppose you have created a build-up section and you want you can say the sectional properties of that member in the form of, you can say, a document. So you just click on this, create a report, and it will open your Word file, and here is your section, and everything will be written here. What are the sheets, the plates you have used for the built-up section, okay, and you can see all other parameters, the calculated parameters are here. So you can put it anywhere, wherever you want, maybe in the design report or wherever you want. So this is a very great tool that Staad Pro has, and you can always check with the manual calculations, right? So if you want me to create more critical sections, you can actually create more critical sections here, and you can calculate manually. Let me just create one. So what I will do, I'll just remove this, I will create new one. Now I will not do the manual calculation. If you want me to create a critical section and do the manual calculation for the different sectional properties and again show it in the software, please do write in the comments so that I'll get to know about it, and I will try to create such videos also. Okay, so let us create a critical section. Now I will not use the built-up section, I will just create using the Indian standard section. So I will go to here, structural steel section and Indian standard. Here you have this I shapes named as S shapes here in the Indian standard sections. Maybe I will take ISMB 550. Okay, and I'll click on OK. So we have got this ISMB 550 and I'll add it. Okay, now let us put a plate at the bottom. So what I will do, I will just select profile, I'll click on plate, and maybe the plate thickness I will consider 12 mm, and the plate width I will consider 350. Okay. Now here, this bottom node we have second two node number 2, and I want to add node number 8 with node number 2. So join node number 8 with node number 2 right here, and I will add it here. So I have added a plate here. Now let us take some angle sections to put at the top. Okay, so I will go to select profile, and I will click on here structural steel section, Indian section, and suppose I will go to equal angles, maybe ISA, whatever you can take here, as we have considered equal sections. So I think I have opened unequal sections. Yeah, let me go to equal sections. Yeah, so maybe any section you can consider, actually any available section, maybe 55 5. Okay, so now suppose I want one section here like this, another section here like this. Okay, so you can do that. Otherwise you can add plates here also like this. Okay, so just let me show you what I will do. I will see this node number 1 will be coming here at node number 10, right? So I will just select join node number 1 with node number 10. Okay, add. So see, we have got the angle section here. Now we want this angle section to be here. So what we need to do, we need to just flip it, right? So how to flip this? I will just mirror it about, see, I have selected, let me just write it here. So previously it was like this. Now while mirroring, it will ask you about which line you want to mirror. So we have two options. One is line 1 2 or line 1 3. So you can see we have two options, line 1 2 and 1 3, right? So if you want to mirror it, rather doing it or rather rotating it, so you can just click on the line about which you want to rotate, the mirror. So here for us the 1 2 line will be working. So 1 2 and mirror. So you can see we have got the mirrored image here. Now this section again, this node number 1 will be coming to node number 12. So node number 1 will be coming to node number 12 here and add. So we have created like this, right? Now similarly you can do here also. You can add two more angles at these two sections, maybe just to show you that maybe it is not of any use, but still I will show you here. Let me just make it upside down. So how to make it upside down? I'll just mirror it about 1 3 line. Okay, 1 3 line and mirror like this, and I will add this number 1 node 1 with node 6. So node 1 with node 6 and add, and similarly I will do the same. I will mirror it about 1 2 first, and node 1 with node 7, add. Okay, so I think you have got an idea how you can create such sections, any type of section you want. And after creating the section, now if you want to check what are the sectional properties you have, you just click on this, calculate basic geometry of the section, and here you go. You got the total area, you got the moment of inertia about y-axis, which is this one. And the best thing is, if you see the neutral axis, now we have a plate here, we have two other sections here. So just let me undo this. Okay, and okay, let me just redo this. So we have got the neutral axis here, right? Now I don't know whether you have seen it or not. What I will do, I will just, okay, let me just undo this. What I will do, here also I will add, now the neutral axis is here, not at the center. Why? Because we have a plate here. Now let me just show you how the neutral axis is shifting automatically with the addition of different members. So what I will do, I'll go to select profile and I'll create a plate of maybe 12 and maybe 6 or maybe 500. Okay, and I want the node number 6 with node number 11 here, and I will add it here. So you can see how previously it was here somewhere, and automatically it has shifted now at the top from the mid center of this member. Okay, so now if I undo this, so automatically it got shifted again at the bottom because we have a plate here. So I will just, okay, sorry. So you can create something like this, and you can again calculate what is the section property here. You can see the section properties, all the sectional properties. You can again get the report here for this member in the Word format, and you can copy and paste it somewhere else also if you want. Okay, so this is how you can create any kind of section in Staad section wizard. You can calculate the section properties, and also you can import this section to the Staad also for the use of your, maybe for to use in your real structure. Suppose if you go to file and you have this export to Staad Pro option, okay, prismatic section or general section, so you can use any of these options as per your requirement. Okay, so this is how this section wizard is very helpful for us. So this is it for this video. I hope you have enjoyed this and you have learned new things here. If you want more critical sections to be calculated manually and checked here in the section wizard, please do comment below. And for any other query, if you have any request for me, please do let me do write in the comments so that I would get to know about it. A few people have asked me about tall buildings. See, it is a very vast scenario. If you see the tall building, even I'm also studying about those things. Once I get to know about the things, I will surely make videos on tall buildings properly, because giving wrong information is not a right thing. So if you see, I have removed so many videos where maybe somewhere by mistake I have given some wrong information, so I have just removed this. Even in my application also, I have removed some of the courses where maybe by mistake, or I may not be knowing all this concept, so I have just delivered it, and when I get to know this, okay, it was wrong, so I just removed that content from there. So that's why I just want to give you the best content as per my knowledge, and I hope like I'm giving it also. Okay, so the learning will be two ways. Please do let me know on which topic you want me to create content, so I will try to create it. Thank you, and thank you again, all of you, all my subscribers, all of you who are watching this video, for making my YouTube channel successful. We have got already 3,000 subscribers, as I have said, and I hope in coming future we'll be having more and more. Thank you all of you again, and see you in the next video.